The North Pacific Ocean, because of the excess fresh water that it has, stands about half a meter higher than the Arctic Ocean and the North Atlantic. And so that makes a pressure head in the ocean, and it forces a net flow northward through Bering Strait. And it's a large net flow. It's like 5 Amazon rivers or nearly 200 Yukon rivers.
It's really, to a large extent, kind of a one-way street from the southern Bering Strait to the Chukchi Sea in terms of the main current flows.
It draws water that's relatively nutrient-rich from the deep Bering Sea basin. And that water swiftly makes it up to Bering Strait and then across the Chukchi Sea shelf. And it's the result of that high nutrient load that makes the Chukchi Sea such a productive ecosystem. The amount of fresh water that comes through Bering Strait actually plays 2 important roles. One, it eventually makes its way back to the North Atlantic to help regulate the global circulation. And secondly, it forms an intermediate layer between the surface of the Arctic Ocean and the very deeper depths that fill up the rest of the Arctic Ocean basin. Now down in the deeper portion of the basin is filled with relatively warm water from the Atlantic side. And if that warm water was able to come up into contact with the surface sea ice in the Arctic Ocean, all that sea ice would melt and the Arctic Ocean would look like a very different place than it does today.
And advection means in both those areas there's some water flowing northward, so towards the Arctic, and that water carries things with it, pollutants for example. For some things it's an endpoint, so for example for some of the animals that get carried with them, with this current, so for example little small crustaceans that are wonderful food for fish, for example. To some extent things come out of the Arctic again, and that's for example ice that comes out with the main circulation patterns, what temperature and salinity modifications it undergoes in the Arctic and how it comes out again has some implications for global climate actually. So, and those processes are changing a lot with the diminishing sea ice cover.
We run circulation models, ocean circulation models that compute the direction and speed of the ocean currents. And these are analogous to the atmospheric models that the Weather Service runs for predicting where storms are going. And the winds and the storms in the atmosphere all have analogs in the ocean. There are swirling storms and eddies in the ocean that are strongly affected by the bottom topography. So ocean flows generally want to follow lines of constant depth. In Alaska, we have a lot of shallow waters on our continental shelves. In the Bering Sea, the Chukchi Sea, and the Beaufort Sea are all pretty extensive, relatively shallow shelves. So bathymetry is really the study of the ocean depths, and it's been important for as long as people have been sailing on the oceans. You need to know how deep the water is if you don't want to crash your ship on the shore. Most ships have some sort of depth sounder, little echo sounder on board, and they also have a GPS, so they measure their position and the water depth. And if that data is recorded and I can get my hands on it, then I will assemble it, and I have assembled millions and tens of millions of depth, latitude, longitude, and depth triplets, and I put them together to make one cohesive chart of the ocean depths.